Fluke Power Analyze is the software used with the 1750 power recorder. It is a Microsoft Windows-based software package. This software allows us to set up the recorder, download analyze data, and generate reports. So let's take a look at how this would be done. First, we'll start with what you would actually do to set up a recorder for a monitoring session. To link to a recorder, you come up to the upper left and scan for units that are available on the network. In this case, I have a direct connection between a 1750 and my computer, and the serial number shows up here. This name or identifier can be changed. By factory default, it shows the serial number. I simply click on it, and then that will form a link between my computer and the 1750, and here it's gone into scope mode. I now will come down to 1750 Setup and click on the icon. It then brings up my two setup tabs that have everything I need to tell the recorder anything regarding the particular connections or setup of this monitoring job. The first section here in the upper left is an area where I can put in information regarding the job or the location or any pertinent information I want stored into the database. This will also show up in the reports. On the left, there are fields here that are factory default filled in, but these are text fields and can be modified. On the right hand side, again, are free flow text fields that can handle any type of alphanumeric or special characters. The next section below is where we can actually remap the front panel of the instrument to compensate for any connection mistakes I might have made, whether that's switching voltage pairs, current pairs, or even if I have a current probe pointed the wrong direction or upside down. To make a change, for example, if I want to change phase A voltage when in fact it's really phase B voltage, I just click on the phase B icon and you'll see that phase A is now showing phase B, and then I'd switch for the second channel to be phase A. So I can remap both my voltage channels and current channels in any sequence I like, but I cannot switch a voltage channel for a current channel or vice versa. Anytime I make a change, once I'm happy with that change and to apply it to the recorder, I come down to the lower right and click Apply. Now in the situation that I may have a current probe upside down, I simply check the box under Invert, and that will change my current flowing the other direction, or flip the probe 180 degrees, showing negative current to then positive current. So if you install a current probe with the arrow facing the wrong direction, you simply can check these boxes and turn the current probe over without having to go back in and physically do it inside the panel. Then to the right of my channel connection change, I have voltage ratios and current ratios, and what this allows me to do is put in a multiplier for voltage or for current. So for example, if I'm coming off of the secondary of built-in switchgear CTs, I can simply put that ratio in, and then this would multiply my readings so that the instrument would reflect the primary side and not the secondary side. Current ratios are not required for the probes that come with the Fluke 1750. Those are auto-recognizing probes, and the software will scale accordingly. The most important section to have filled out correctly is the configuration. This is the one section that is required before monitoring to have set up correctly for accurate measurements. The first is your power configuration. This is where you set the type of transformer that you're being fed from. And as you can see, when you click the down arrow, it lists the most common transformer types. So then you simply choose the power type that best fits the location that you're connected to. The next one is selecting your nominal voltage. So this would be the voltage that the unit is seeing on the input to the instrument. Simply hit the down arrow and select the voltage that's closest to what you have connected. However, if there isn't a selection that meets your particular situation, you can simply type in the value that you feel that works the best. And as you can see, when I put in a value, it's represented as phase to neutral and also phase to phase. The way that the instrument sees this, for example, if you're on a three-phase Y configuration, the unit is going to recognize the nominal voltage as what's being input between the phase and the neutral. If you have three-phase delta selected, the nominal voltage would be based on a phase-to-phase measurement. So in this configuration that I'm working with, I'm going to set it up for 277 three-phase Y. And then lastly is the nominal voltage. And here we make a selection between a 50 Hertz or a 60 Hertz fundamental frequency. The next section here summarizes the settings for the event limits, which are basically tied to the summary screen. Now these are grayed out because these are actually set from another screen located under settings. So if I come up to the top toolbar and click on Settings and go to Limits for Summary, it then will bring up a whole nother screen that allows me to set all the thresholds that are used in the summary screen. The summary screen is a really nice dashboard that gives us an indication of what our power quality looks like when we first open up a database. And we'll go into further details on that a little bit later. But right now, this is where we would set up those limits to control how that summary screen behaves. The factory defaults that are programmed into the software come from a standard called EN50160. However, we do have a couple other standards available that are built into the software. To access those, simply come down and click Open, and here you'll see the choice for the IEC 6100-2-4. If I want to use that, I simply click on it and then come down and click Open, and those defaults would then be loaded in. I can also modify these to anything that I want it to be, and then click on Save and save my own template. Most of the values are just simple text fields that you click on and then type in a value. For the harmonics, what you would do is grab the cursor bar and select the harmonic order you're interested in changing, and then type in the values down below. Or you can use the up and down arrow to manually select. Then any changes that you make to one of the factory default templates, you then can click Save As, and then save it as your own under a name or location that you would prefer. And then whatever settings that you change in the limit screen will then be reflected in this event limit summary section. From there, we have the snapshot interval. And what this does is tell the unit to take a snapshot of all the channels for voltage and current on a timed interval. We can select anywhere from none to 10 minutes, 30 minutes, and a 1-hour interval. And that data will be then stored in the database in a separate location, which we'll review when we start looking at stored data. And then remember, anytime you make a change, you'll want to click the Apply button to actually send those changes to the instrument. Once we're done making the changes here, under the Instrument tab are a few more settings. The first one is the ability to change the default name that shows up in both the software and on the wireless handheld device. Again, by factory default, this will be the serial number of the instrument, but we can change this to anything that we would like. If we've got a couple recorders on a network, we might actually want to change this to where they're physically located so we know which is which. Then below that is the ability to set the clock inside the instrument. We can do it manually, or we can simply click on Sync to PC, which makes it real easy to adjust the clock in the unit, but make sure that your PC time, date, and time zone are correct before doing this. Then over here to the right, we can control how the instrument sets itself up for the TCP/IP network communication protocol. We can choose whether to obtain an address automatically from the network, which would also be used as a default address when we're communicating as a direct connect between a Windows PC and the instrument. Or we can tell the instrument what IP address to use manually. And this is typically used when your IT department gives you an address to specifically program into the instrument rather than having an automatic one generated. Then the next section allows us to actually set a password inside the unit such that no one can connect with either a computer or a wireless device without knowing the password. Then the last one down below is the current probe detect, and what this does is give us a listing of what current probes are connected to the instrument. And this is useful to use as a troubleshooting tool in case you're having a problem with the current probe, you're unclear as to whether that probe is working or what type of probe it is. And also, since we have self-identifying current probes, we can mix different types of probes on different channels. So again, making sure we've got the probe that we want on the channel that we want. So those are all the settings available as far as programming the instrument. And most importantly, remember to always come to this configuration screen before each monitoring job and make sure that the power type, nominal voltage, and frequency are set correctly. Those are the three items that are critical before you actually start monitoring, other than making sure that the instrument is connected correctly to the voltage and current. So as I'm talking about making sure the instrument is connected correctly, you're probably wondering, well, how would I do that? Well, let's take a look. So to find out what is actually being seen by the instrument, we can come over to 1750 Live. And when I click on 1750 Live, it takes me into the scope mode. And from here, I can see my RMS voltages and current for each channel, along with my frequency on the top toolbar. And I can also look at my waveforms for voltage and for current. To tell the software what channels that I want turned on or off, I simply click on those over on the right hand side. And if I want, I can have all channels turned on. Now you'll notice that when I turn my current channels on, they're pretty well squished here in the middle. There's a little hidden trick in the software, and that is I can right click on any of my scales and choose an auto or a zoom to fit or manual. And when I click on that, it will then auto scale whatever I'm adjusting. So I can do it for voltage. So come over to the scale, right click, bring up the menu, and I can click zoom to fit. If I like, I can also set a manual scale, again by right clicking on the scale and accessing the menu. This scaling feature is only one of two things that are not directly accessed by one of the toolbars on the display. The second is if I wanted to add another cursor bar, I can simply right click on the cursor bar that's on the screen, and I can then toggle on my horizontal cursor bars. So two little tricks. Again, auto scaling, and then right clicking on the cursor bar to turn on and off the horizontal scale bars. Everything else will be an icon or a menu right there in front of you on the display. Then as far as the waveform display, I can do everything overlaid, or I can come down here and split it out by clicking on stacked, and I can look at each channel individually. So this would allow me to look a little bit as far as my connections and comparing the voltage and current to each phase and how they line up. But a much easier way to determine if I'm hooked up correctly is going over to the phasor diagram. So I come up to the upper toolbar and I click on phasor. And there's my phasor diagram for voltage and current. Now in this connection, my currents are very, very low in comparison. So as you can see, my currents are pretty much down here in the middle and not very useful. What I can do is I can come over here to the right where my scaling tool is for my voltage and current, and I can just click on the up arrow, and as you can see, my scale is then adjusted and my current vectors appear, and from this point I can make a useful decision on how I'm connected. So those that aren't familiar with the phasor diagram, I'll go through a quick explanation here. What we have is an arrow for each phase of voltage and an arrow for each phase of current. And they're each color coded based on the color coding that I chose for the instrument. In this case, it was set up for US color coding, being black, red, blue. So I have an arrow for phase A voltage here that locks in at 0 degrees, and then here's my current just a little bit below it. And then for phase B, the same thing. Since I'm on a Y setup, it's representing it as phase B to neutral voltage and my phase B current. And then the same thing here for my C channel. Now if I had my current probe upside down for phase A, it would show 180 degrees out because the current would basically be flowing the opposite direction. So this gray A arrow would actually be over here on the left. So if you see a current arrow that's basically opposite of where you would expect it to be, or 180 degrees off, you probably have a current probe upside down. And then you could go over to setup and check that box for invert, and then that would then flip it back over. If I happen to have a red and blue arrow here down in the lower left, that would probably denote I have a voltage and current pair mixed up. So we're looking at where the location of the arrow is and also what color is in that location, and making sure that our colors are paired together. And the way that this phasor diagram is designed is it's looking at the electrical phase sequence, and what we want to see represented is phase B in the lower left. And by going with the assumption that phase B will always be in the lower left, then we know when we have a color mismatch whether it's going to be the voltage or current that is off, because we'll know that B should be in the lower left. Now again, this has to do with the connections and verifying that we're wired up correctly. This isn't meant to denote phase rotation or which way the motor is going to spin. So when we talk about ABC or CBA rotation, this isn't where we're going to be looking for that. That's not denoted here. We're focusing on how the instrument is connected, and that's why I recommend that you should always see phase B in the lower left. So on the screen we also list out the fundamental values for voltage and current along with the phase angles. We can turn channels on and off, and then again being able to scale our arrows to make it a little bit easier to read for both voltage and current. But we have a couple other things in scope mode. The next is meter mode, and this gives us real-time view of what we're seeing on voltage, current, and power for each one of our channels. Now, we also have a value for percent total demand distortion, and for this to be calculated correctly, we need to come over here and tell the instrument what the maximum demand load current would be, and then based on what the maximum load current value that we plug in, it then can calculate what the percent TDD would be. The harmonic view allows us to see a bar graph of all the harmonics, and in this display it only goes up to the 25th, but if I grab the bottom scale I can click and drag and go all the way up to the 50th. But typically we're looking at much lower numbers. If I want a better definition of a particular harmonic, I can just click and drag the cursor bar to the harmonic of interest, and wherever this cursor bar is, I get this balloon here that gives me the numbers, but I also get more detailed information down here below as far as each channel percent THD, breaks it down to odd and even, also for my current, and my K factor. So to look at an individual harmonic, just drag the cursor bar to that harmonic. It'll give me what the value is for that individual harmonic that I've placed the cursor on. But in most cases, people are targeting what the percent overall or percent THD is for voltage and current, which is down here below. And then, as typical in all the screens within the software, over here on the right hand side, I can manipulate the data that I'm viewing. So in this case, I can toggle between voltage and current. I can turn channels on and off. I also can change the reference. So when I'm looking at my harmonic values, are they a percent of fundamental, or do I want to display them as a peak or RMS value? I can also turn on and off inner harmonics, and also whether I want to show the fundamental. And the reason why turning this off can be useful, because the fundamental is usually always going to be a high value and can end up scaling the graph such that everything else is shown very small. And even if I auto scale it, again, the fundamental is locking me out to these lower values. So if I turn off the fundamental, then I can get much better resolution for the smaller harmonics. And again, for proper calculation of percent TDD, I need to put in what my maximum demand load current would be. And the last tab in Scope View is Power. And here I have a representation as an analog gauge, my kW, my VARs, and my power factor. And then down below I have text data for each individual phase in total for those values. And again, over on the right, I can turn channels on and off, and also choose between true power factor or displacement power factor. Okay, so at this point I have configured the recorder, and I've gone in and verified that I'm happy with the connections and the data I'm capturing. So what's the next step? We're going to tell the instrument that it's now time to do its job. And I've got two choices as far as what I'm going to do with all the data that's been gathering while I've been playing around setting up the instrument and also checking my connections. Because again, the 1750 is always recording when it's plugged in, so all this time it has been recording data, and if I haven't cleared out the data from previous jobs, that is in there also. So my personal preference is I like to erase all the memory at the beginning of each monitoring job, so that way my databases stay nice and clean and segmented. So to do that, I would simply come up under Tools and choose Erase 1750 Memory. And what this would do is as soon as I click on it, it's going to erase everything that's in memory up until the point when I hit Erase 1750 Memory. So that way my database doesn't have any of the garbage associated with me connecting it up and reprogramming it. It starts off nice and fresh from when everything's set up correctly. But the other option I have is I can insert an annotation. And from here, I basically can put a flag in the data saying start. So there'll be a flag in the trend data that will denote a start point. In other words, from this flag, all the data is good. Ignore the stuff beforehand. So there's two ways that you can manage your data. I personally just prefer erasing the memory so I know it's nice and clean, but you also can use the start and stop annotations to denote beginning of good data, end of good data, or you also could use these as basically flags of beginning of test or end of test, and also set up multiple flags if you've got multiple tests that you're running. The annotations can also allow you to input a text value. For example, if you're doing a generator test, you could actually type in what step you were at what time. And again, this goes right into the data stream, so you don't have to look at a notepad and time stamp things and write what you did. You can put that right into the data stream. Now, one thing to keep in mind is everything that we've been going over so far in the Power Analyze software can also be done through the wireless device through the Fluke Power View software. So all of this is redundant functionality, whether you want to do it through the PC or through the wireless device. It's your option on how you'd prefer to do it. Okay, let's pretend like we've just moved the clock forward. My instrument has been sitting running from since I've connected it up for a period of time, and now I come back to the job site and I want to download the data from the instrument. What would be the steps? Well, again, I'd come and select the instrument that I want to connect to, and then I'm going to click on 1750 download. So 1750 download is what I would select to pull the data from the instrument over to my computer. From here, it'll give me a summary of the data that's in the instrument. And it's a very low resolution trend chart, and you can see I have an event here. But you can also see all the other phases over the period of time I've been monitoring. And by default, it'll fill in the beginning of the monitoring period to the end of the monitoring period. So when I select 1750 download, it's going to automatically set to download the entire database. But what if I only want to download a small portion of it? I can either click on these text fields down here on the bottom and actually manually put in a time or date, or I can just grab these cursor bars and zero in on a period of time. So for example, I might only want to download the data around this particular event. But I'm going to go ahead and grab the entire database. So again, I'm going to take the cursor bars and move them all the way out and just click on Save. And then at that point, it's going to say, okay, what file name do you want me to save it as on your computer? So I can simply type in a name for the file that I want to save on my computer, and also take a look at where the data is being saved in case Windows has put it in a directory that wasn't the one that you wanted it. You can simply change the directory up here. Once you're content with where it's going and the name of the file, click on Save. And then at that point, it's going to start pulling the data and copying it from the instrument to your PC. And it is not erasing the data out of the instrument. The instrument is still capturing data and adding to the database. So this does not affect the monitoring or the database in the instrument. We're simply doing a file copy to the PC. Once the data finishes downloading, it then brings us to our summary screen. And again, this goes back to those limits that we were working with earlier in the software. And this dashboard gives us a quick overview if we have any problems. So if we look at this, our frequency seems to be within the thresholds. Our voltage variations are okay. Our harmonics obviously went off scale or outside a threshold, along with our flicker values. So green bars are basically telling us that everything was within those thresholds, and any red bars tell us that they were outside. If we move over to the right hand side, we can actually look at other views related to the summary screen. If I click on events, it takes me to a table view of any events that I may have captured, tells me the quantity and also the minimum and maximum values and the duration. So it's a nice little text listing of what had happened as far as any events captured. And I also can do a drill down into my harmonics, and it'll flag which harmonic was actually outside the threshold that I had defined earlier in the limit screen, or if I just left it at factory default, it was probably using the EN5160 values. So that's a nice, dashboard as far as pass or fail, but let's take a deeper dive into the data. So the first thing, I'll come over here to volts, amps, hertz, and this is the trend chart for voltage, current, and frequency. And again, over on the right hand side, I can choose what channels I want and what values I want on the graph. And right now I'm just looking at my three phases for voltage at a default configuration of phase to neutral. Now, this voltage reference is actually pretty useful on a troubleshooting standpoint. For example, if I had my unit configured for a delta and I had an event and I wasn't sure whether it was on one phase or the other, since everything's represented phase to phase, I can simply change it to a phase to neutral representation, and then the software will identify or break out that individual phase even though it was a delta configuration. And on the same lines, if I was on a Y system and I was unclear if something was happening on my neutral, I could toggle between a phase to neutral to a phase to ground. And that way I can isolate further. Okay, let's move back to the trend charts. So what I have are two graphs, this upper graph and this lower graph. And the difference is this upper graph is always a 10-minute average. You can't zoom in or change that. The bottom graph is what I call our working palette. This is where I can actually zoom in, get better resolution, and make changes to the actual data as far as how I view it. So the purpose here is if I see something on the upper graph of interest, I can grab my cursor bars. Wherever my cursor bars are set, the lower graph then becomes the data that's between those cursor bars. And that allows me to get into data of interest very quickly. So again, the upper graph is a 10-minute average, and it's our summary. The bottom graph is our working palette. Now, some people prefer to only have the working palette. They find this upper graph a little bit of a distraction. What you can do is come up here to the upper toolbar, and we can make the working palette full screen and just get rid of that summary screen altogether. So these two icons at the top allow me to bring either screen full screen. So bottom screen, full screen, top screen, full screen, or go back to split screen. Another nice feature is the next two icons allow me to take it from a graphical representation into the actual raw data itself. So rather than exporting to Excel, if you have questions on a particular point or data, I can quickly toggle between the graph over to the raw data without having to bother exporting to Excel. So let's take this back to the beginning. So I'll zoom back out where we started, and that's what these green arrows do, is basically take us to the beginning point. And I can move my cursor bars out to the whole monitoring period, so the top and bottom are basically the same. And from the bottom graph, I can actually do a manual zoom. So I click on the icon here for a draw box, and I can just manually zoom into this event. And I can zoom in multiple times. And if I don't zoom or make my draw box correctly, you'll notice I've gone off scale. So remember that trick of right clicking and just go to auto scale, and then it brings it back into frame. Now, one of the fun things about the summary screens is I can actually just continue to zoom, and as you can see I have an event here, and if I just keep on zooming, I'm going to reach a point where RMS then goes to waveform. So as I zoomed into that event, you can see right here my phase dropped out. First phase C dropped out, and then phase B dropped out, but A continued. I can also grab the horizontal scale and just drag and just walk the timeline of what happened. I can also come back up here at the top toolbar and zoom in and out manually. And again, if I don't like the scale, I can just quick do an auto scale or a manual scale. And I have my measurement bars, and I can turn on my horizontal one, so I can measure basically the delta between these two bars and also the time between these two bars. So a lot of scaling tools available here. So just in the trend charts of voltage, current, and frequency, there's a tremendous amount of data that I can dig into. But when we're looking at a pretty active system, doing this manually could be time consuming. So if we go over to events, this is where the software will look at all the data and analyze it for us and basically bring the events to us rather than us having to chase the events manually. When I first go into the event section, it's going to lay out these events over the time period or the monitoring period. And as you can see, most of our activity was right around here, so everything is time-based. And anytime I click on a dot, it's then going to bring that event down to the bottom. So the top is an overview of the events, magnitude versus time, and then the bottom is the individual event itself. And I can look at events based on voltage or current, and again I can turn individual channels on or off. Now, in most cases, you're going to want to look at your events based on thresholds. And that's one of the real powerful features of this software is I can apply thresholds after the fact and have that data then pulled forward. So to do that, we'll go over to tolerance, and we can look at it all represented as a magnitude versus duration. And from here we can choose our preference on whether we want the ITIC curve or the Sabima curve, depending on our preference. And go into the event detector and put in the thresholds that we want. And all of this is dynamic. I can change this as much as I want whenever I want. So instead of 10%, I might want to change it to 5%, or actually plug in what that value would be. I can do it individually by channel, or I can just make all the channels the same and basically save time by not typing it in over and over. So if I apply a 5% threshold for all my channels, and then I click apply, we then apply that to the data and it brings forth any events that then meet that criteria. Now you notice that nothing really came forward at that time. Let's take a look over here where it's saying combined. And what that means is it's only going to bring events that happened on all three phases. But I want to look at each phase individually. So I'm going to change it per channel and then click apply. And then you'll notice a few more events showed up that were just isolated to individual phases and not happening on all three phases. And then over here on the right we have our threshold for our transients. So instead of 500 volts peak, I can set that down to 100 if I like. And then aggregate events within. What this is the software is going to take any events that happen within the time frame that we specify. So for example, if I were to put 3 seconds, it would combine all events around that 3-second period and simply plot them as one dot. So I changed my transient threshold to 100, so I'm going to click apply, and then all of a sudden we see a couple transients show up. Once I'm done playing with my thresholds, I can click on done, and then from here any event that I'm interested in, just click on the dot, and then that event then shows up on the bottom. I can walk the timeline by just grabbing the horizontal scale and do a click and drag. Again, I can adjust my scaling by doing a left click and drag, or doing a right click brings me back to my auto scale manual scale. If I want to see what current was doing, I could simply turn on my current channels, turn them off, auto scale, bring those in. So the right hand side basically is pretty consistent as far as manipulating, having channels on or off, or what data that you want to view. Then the next group of data is our harmonics, and from here I see my FFT, or the bar graph of each individual harmonic, and similar to what we saw in scope mode is I can simply bring my cursor over an individual harmonic, but down below it's a trend chart over the whole monitoring period for that harmonic. So this is basically my max and my average of the harmonic. And as I move my cursor bar, I choose which harmonic I want trended down on the bottom through the whole monitoring period. So I have the capability of trending each individual harmonic for voltage and for current up to the 50th through the whole monitoring period. Another way that we can look at our harmonics is switch over to THD. And on the upper graph, this is an overview of our THD for the whole monitoring period, but I then can take my cursor bar and at any point in time get a breakdown, or the FFT, of all the individual harmonics at that point in time. So a couple different ways of digging into the harmonics. Then moving on to the next tab brings us to Flicker, and this is our trend chart for PST and PLT, which are the two values that are tracked within the Flicker function. So similar to what we saw in volts, amps, hertz, we have our summary screen here on the top, and then down on the bottom we can then zoom in and work with our Flicker values. We can also decide whether we want PST and PLT individually or both together. Then the last tab is power and energy. So again, over here in the upper right, I can select what values I want in my graph, whether individual phase or total, for watts, VA, VAR, and power factor, and they will then show up on our trend chart at the top. Wherever I put my cursor bar will then be a breakdown below of the actual text values of wherever that cursor bar is located. So I can get really good resolution of my data at any point in time. Over here back on the right again in manipulating my graph, when you think about demand, we typically are looking at a 15-minute averaging period as defined by most standards and how a lot of utilities are looking at it. So here we'd select a 15-minute averaging period. So the averaging period for demand is actually set on a post basis rather than defining it at the beginning when we set up the instrument. And then below we can toggle between power values and our watt-hour values or our energy values. And again, the demand period that we select here will be represented in energy. Now the last group of data that's stored in the database is our snapshots. So when I click on View Snapshots, that will take us to those snapshots that we defined to be gathered on a timed interval, or if we triggered one manually. So the snapshots are basically stored on an individual basis. So if you set it for a 10-minute, we'd have a snapshot every 10 minutes, and that would be represented here on the time bar. So I can just grab this and switch between each individual snapshot, or I could also use these arrow buttons and move one by one. And these snapshots are identical to the scope live view that we were looking, but again, these are frozen snapshots in time. So the functionality is all the same that we saw in scope mode as far as being able to access phasor, meter mode, harmonics, and power. But again, these are frozen points in time as represented by the timestamp up here and not dynamic live screens. Now the final piece of the software is the report generator, because typically once you've gathered all this data, you need to generate a report. So how would you do that? Well, if you look over here on the left hand side, there's an icon for auto report. But there's also an icon over in the lower right on all the screens we've been looking at that say tag for report. So let's talk about how these two features work. So what tag for report does is it actually puts into memory any screen that you're looking at. So any individual screen that I find of interest, I can simply hit tag for report, and that individual screen then goes into memory. If I had modified it or made changes to it cosmetically, when I hit tag for report, it's frozen in time, and that's what ends up going into memory. So tag for report is just individual screen captures basically, or a hybrid cut and paste. But auto report, on the other hand, is a very comprehensive automatic report generator. And what this will do is allow us to go into great detail in customizing what data we want in the reports and how we want them actually presented. And we can also break it down into a time frame so we can focus it on a period of time. So starting off, we can set again the time frame we want the report to cover. We can also split it into sections. So if you think about monitoring for a long period of time, we might want the report to break that 1 month period up into, say, a weekly, or if we'd monitored 6 months, or maybe we only monitored a week and we want to break it down into days. The report writer will allow you to do that. Now as you look over on the left hand side, you can see that there's a lot of choices, and in each one of these there's a lot of things that we can do as far as channels, how we want it represented, what values. So again, a tremendous amount of data can be pulled into this report, and it can be very time consuming going through and customizing all these values. So another thing that we've done is we've created templates. So right here it shows the template that is actively being used, and this is the complete PQ report. And we have several templates programmed into the software. So if I come down here and click on load, I can choose between some of the templates that come in the software, but then I can also modify any one of those templates. And then once I have a custom report of my liking, I can then click Save As and create that as my template. So a couple different ways that you can go about this as far as customizing these reports. And then you can see down here the tag for report choice. Those items that I had clicked tag for report then gets pulled into this automatic report writing. So I clicked tag for report when I was looking at that phasor diagram, so it's listing here anything that I had clicked tag for report on. In this case there was only the one item. So once I've adjusted all the values the way I want them, created my own custom template, or I'm using a predefined template, from there I can select how do I want to output the report. I have a choice of a preview that basically just brings it up to the screen so I can view the report, but I really can't do anything with it other than view it on the screen. I can output it as a PDF file, which is very, very common, or I can output it as a rich text format, which basically allows me to bring it into Microsoft Word or something that's compatible with RTF, and then I can continue manipulating and writing. Maybe I want to copy over some thermal image captures that I have. Anything related to the job that I'm doing, I can then bring into this report in addition to it just being a generic power quality report. So in this example, I'm just going to choose an open preview so you can see what the report looks like. And then once I'm done with making all my modifications and my choices, I simply click OK, and the report writer will then go through the database and create the report for me. Once it's done, it brings up the report, and here you can see the summary screen. We have 59 pages that it created. So I'll just scroll through some of the examples. So on most of the main headers there's a little blurb talking about the section and what it is basically representing. And then it copies over the graphs. And it also goes in and pulls a lot of values of the raw data. So it's looking at minimum and maximum values and what time they happened. So again, it's going to do some analysis of the data as far as bringing a lot of worst case and what that value was and the timestamp of that value. So not just copying over graphs, doing a little bit of analysis also. So as we get down to events, it's telling us how many events, what type they were. Then we get to harmonics, brings over all the graphs, and then does a tabular breakdown of each one along with flagging the ones that were outside of limits. And we'll keep moving through. Harmonics is a pretty long section. Then we get into our trend charts. So again, it brings over the trend chart based on the time frame that we told it to run the report, and again our min-max values and when they happened. And so it's going to do this for voltage, current, and frequency. So I think at this point you get a good idea of how the report writer works. Also, one thing that I forgot to mention is this graphic can also be changed. So by default it brings in the Fluke logo, but you can go in and substitute the Fluke logo for a graphic of your choice. Okay, so at this point we pretty well have gone through all the features within the software. The one last thing is, how would we actually work with database that we've previously stored on our computer or have been shared by another coworker? And to do that, you simply come down under File and choose Open. And from there you just direct it to where that file was located and then open it, and then the behavior will be exactly what we went through on the downloaded data. So whether you're viewing data that was downloaded from an instrument or you're opening up a save file on your PC, that's how you would then access it. So we've gone over all the functions of Power Analyze, from how to set up the instrument, how to verify that you're connected up correctly, and how to get to downloaded data, view stored data, and also generating reports.